Peter Davis teaches a course in marketing. He uses the system shown to the right for assigning grades to his students. From the information in the table, what percent of the students receive the grade of B? So in this table we have, for the grade of B, he's assigning a score where we see X bar plus 0.2 standard deviations to X bar plus 1.5 standard deviations. So this is set up as a z-score, and based where they are on the line, they'll get a certain percentage. So what we can do is we can use the z-score formula. The z-score formula is your score x minus the mean x bar divided by s standard deviation. And we need to convert both of these scores to z-scores. So the first score we're going to convert is the one x bar plus 0.2 s. So what we have right now is we have on a normal distribution curve, we have the mean x bar in the middle, and there's a score which is 0.2 standard deviations to the right. So if I make a mark 0.2 standard deviations to the right, that's where this position is. So if we substitute into this formula, x is actually this score here. So I'm going to substitute x with this expression, x bar plus 0.2s. And that gives me x bar plus 0.2s minus x bar divided by s. If we simplify on top, we can cancel the means because one's positive and one is negative, and that leaves us with 0.2s divided by s. And in this step, the s's divide into each other one time, leaving us with just z is equal to 0.2. You can see that's exactly where I landed on the number line when I move 0.2 standard deviations to the right. So this actually is the z-score. So if we look at the second score, which is x bar plus 1.5 standard deviations, that means I'm starting at the mean and I'm moving to the right 1.5 standard deviations. And so if I went ahead and substituted into the formula again, I would end up getting 1.5, the same thing. So you really don't have to do the formula work. You can just say that you're going from 0.2 to 1.5. So shading is important next. Which direction under the curve do you want to shade? Well, we want to shade in the middle of these two scores because any student who lies in this region is going to get this grade percentage. They're going to get a B. So if I now look up the first score, z equals 0.20, in my z table, we want to find the area. So make sure you're scanning in the z columns and not the a columns, and we're looking for z equals 0.20, and you'll see to the right of it that the area is 0.079. So it's important to know that that is the area going from the mean to, so from 0 to your line. So that area in the picture is 0.079. Next, we're going to look up the second z-score, which is positive 1.5. So 1.50 is up here, and it has an area of 0.433. Again, that's going from the mean all the way to the line 1.5, and that whole area is 0.433. Now, these two arrows overlap each other. So when they overlap each other and they're going the same way, if we want to find the shaded region between, we just need to subtract those areas. So 0.433 minus 0.079. That's going to give us the shaded region. So this difference is 0.354. So the percent of students who will receive the grade of B according to the distribution of this table, and they want us to round to the nearest tenth, is 35.4, and that's what you would type in, %.